So today we are starting practice on array sorting and searching. Array sorting and searching techniques. So the project name is sorting and searching. So here I'm just creating one array and let's say the string array, because usually in paper 2 they will give you one array of objects, and on this array of object they will ask you to find name of someone or something like this. Okay, so next I'm explaining it with the help of simple array. I'm not creating a string array, in fact I'm creating simple array. So this is the syntax of declaring array in Java. And let's say the 10 elements we have, or instead of creating this, I'm just taking some random numbers. 89, 23, 54, 554, 67, 60, and 100. So 1, 2, 3, 4, 5, 6. In this array, we have 5 elements. Okay, this is the array.
Okay.
Okay, I will connect this code. First, we are understanding logic on the basis of simple array, and then I will connect this code with the array of object. Okay, so
Okay.
say the very first code is linear search. Linear search. If you are looking for something in the array, we are passing array parameter. Okay, one important thing that you must know, SL and HL student both must know how to pass array as a parameter. Array, how to pass array as a parameter in any method, and what is the syntax if method returning array. If method is returning array, you must know the syntax. This is very important for tomorrow's exam, object oriented programming. So here I'm passing one number. Let's say I'm taking one number here, 60. Array name is ARR. So by this way, we can call any method and we are passing array name and the variable. Now I'm writing signature line, public static, but in your exam, you will not write a static. Here, I don't want to create object. That's why I'm making method static. But in your exam, you write a static. You will just write return type. So return type is void and the method name is linear search. Linear search, and in bracket int square bracket a int element that you are passing. So now again I'm explaining it. Whenever you are calling any method, just a minute, let me correct the spelling. So if you are calling any method and passing one array as a parameter, you have to ensure that array has some values. Then you are passing, you are just writing the name, no blank square bracket. But in the method signature, this part is known as method signature. This part is method signature. Method signature definition is also important in IBDP. Method signature means in the method definition, only the method name and the parameter list and their type. So if method is accepting any array as a parameter, what we will do, we will write data type, square bracket, and the array name, whatever name you want to give. So it is basically valid identifier. And that's it. This is the syntax. Sometimes you can write data type, then identifier. Identifier means the name you want to give to your array, then blank square bracket and this thing. So this is the syntax, and you have to be very careful. If you are missing blank square bracket, your examiner will deduct your marks maybe, because this indicate it is just a single variable. But if you are writing these blank square bracket, it will indicate that this A is not a single variable, it is entire array. Now we are running one simple logic. We are creating one Boolean variable flag, or we can say found, which is initially false. And if found is false, after entire process, we will consider it that number not found. If found is true, we will consider okay, number found at some location. So we are running one simple loop for index 0, index is lesser than capital A dot length, and then index plus plus. So you can see, you can notice that here the real array is ARR. Execution starts from here, and you are passing this real array with name ARR. But once you will execute this method, the copy of ARR will go to the A. So this means these parameters are actual parameter. So what is actual parameter? These are the parameter having actual values in the method call. This part is method call. This part is method call. And this thing is method definition. This thing is method definition. And the copy of this ARR will go to the A. So this means if ARR was like this, 67, 89, 23, 60, and 100, we have another copy A, and this array copy is here with value 67, 89, 23, 60, and 100. Okay, so it is absolutely fine if the name is not same as actual parameter, because these parameters are formal parameter. They are just keeping copy of the actual parameters. So if names are not same, it's absolutely fine. And so that's why we are using A dot length here.
Okay. And the index I can write as I, right?
You can write that. It is your call. Index equal to 0, index is lesser than length, index plus plus. Because again, this index is nothing. It's just a variable which is keeping track of all the indices of the given array. And you already know this thing, that array always starts from index. Which index?
0.
So that's why from 0. Then if A dot length, length is the property. Sometimes what I'm noticing, students are writing this line like this way. They are writing A, then dot length. This practice is absolutely wrong. Length is not a function. It's just a property of array. So you will always write array name, then dot length. Okay. So length is the property of array which will return number of elements. So how many elements we have in this array? 5. So the value of length is 5. And that's why we always stop this loop at one lesser value. Why lesser value? Because the last value is always at length minus 1 position. Simple logic. If element is equal to A of index, then we will just print element found at position index, and we will just break the loop. Breaking the loop means you will come out from the for loop. So break means break is a keyword in Java. It is used to break the innermost loop. So you will come out from the loop and you will not process other elements. And you can do only one thing, found. Found is equal to true in this case, because once your value is found, it's you are changing the state. This is the for loop. Outside the for loop, you will write not found. You can see in Java, this symbol is not. This is the not operator. So if you are applying not operator in front of true, this entire statement is false. And if you applying not operator in front of false, this entire operation is true. So how we will read it? Not found. If not found, this means your element is not in array. So if not found, you will just write not found, element not found. Okay, and that's it. This is the closing of for. Okay, we have to write this statement outside the for. So you can see here loop ends, and outside the loop we are doing this. So if we are going to run this code, so you can see 60 found at position 3. So this is this value 60. If we are writing 100 and then running this code, 100 found at position 4. I hope this code is clear.
Yeah.
Right.
And then I found 2.
Tomorrow you have to be very particular about the syntax
Yeah.
of Java, because you can't write pseudocode kind of thing, because in pseudocode you were using only single equal to sign. You can see here I'm using double equal to. It's a equality check operator. It will check whether left side is equal to right side or not. Okay.
And do I have to use the not operator? Can I just say found equals to false?
Yes. Whatever you think is easy for you to understand, you will write like this way. It's the same story. If found is false, we will say not found. Okay.
Okay.
Now, public static void binary search. Binary search code, and you will help me in this. Int, again the array A, and element is, let's say, element. We are looking for this element. Now you help me, whatever you remember, you will just tell me, I will type binary search. So binary search means, we can't perform binary search unless your array is sorted. So for now,
Yeah.
what I'm doing, I'm considering this array is in, I'm taking array in a sorted manner, let's say. So this is 90, this is 100, and this is 200. Okay, this is my array. Right?
Mhm.
So 67, 89. So array is already sorted in ascending order. In ascending order. Now we are searching for something. Now you will tell me what you remember regarding binary search. This is the array. I'm writing all the elements 67, 89, 90, 100, and 200. This is index 0, 1, 2, 3, 4. We will always create one index, one variable low with the value 0 because it is a starting index. We always create one variable high with the end index. So for safer side, you can just write a dot length minus 1. So in your exam, we are not sure what will be the length of array. So whatever the length, your last index is always at a dot length minus 1. On this basis, you will calculate mid. So int mid is equal to low plus high divided by 2. Now here you don't need to bother about div, because if you are creating variable int, this is int, and then obviously if answer will come in point, it will ignore. Int means it will just ignore everything after decimal point. Okay. So let's start working on this, right?
Yeah.
So, tell me. Int
So first int up
low equal to 0, comma,
low equal to 0, comma high.
a dot length minus 1. Then we are creating one Boolean variable found with initial value false, right? Now, while loop. What should I write in the while loop? You will help me. And in the while loop, we will do something. Why we are using while loop? Because we are not sure how many times we have to come in this array. Because sometimes you will find, sometimes whatever you are looking for, maybe you will find this number at the mid position. Then you don't need to run the entire process. Just come out from the loop. Sometimes
Yeah.
you are processing everything, you are keep dividing. So when iterations are unknown, you are not sure about the number of iteration, how many times you want to execute the loop, then in that case while is most suitable. Okay. So while,
Okay.
tell me while.
So while found is false, I think, right? Well, int equals to 0 and found equals
It's
false.
false. The another way is this one, while not found. But if you
Yeah.
are comfortable in this, the same thing, while found equal to false, and at the same time, what? And this is
And wait,
low is less,
low equals less than high.
right?
Yeah.
Because once your high is greater than low, it will indicate that you processed each and every element and you didn't find the element. Okay, so low, it will always go. Low index will always move. Just a minute. Low will always moves towards right side in case of ascending. In every case, low will move towards the right side. High will move towards the left side. But once they will overlap, low is going here and high is reaching here. It indicate you process these elements and you didn't find it. Okay.
Mm-hmm.
So while low is lesser equal to high, only till then we will solve this. We will process our search. So mid equal to low plus high slash 2. Okay, this is our mid. So you can see initially low is 0, high is 4. 0 plus 4 divided by 2, mid. So this mid is 2 right now. Now, if you are looking for any element, so there are three possibilities in binary search. You are breaking your array in two halves. Either your element is at mid position, or it is lesser than, or it is greater than. Means you have only three criteria to check. So if
Mm-hmm.
what should I write in the if?
So if the three criteria are if you move with the low and you can't find it, then your low will become your mid, right?
Right.
So
No. Your low sometimes. Okay, first we are checking. Let's go slow. Let's go step by step. First, we are just, is this A of mid? Because every time you will compare your element with the mid position. So if your A of mid is equal to element, what you will do? You will just change the value of found. Found becomes true, and you will just output um, element found at position. Which position?
at the A mid.
Right, at the mid. Mid is the index. So at position mid, right? So A of mid means 90 because mid value is 2. And if you want to fetch this value, what you will write? You will write A of 2. So if A of 2 is equal to element, this means element found. Just change the found value true so that you can come out from the loop and you don't need to process other elements basically. And
Yeah.
this is not a case. If this is not a case, then what you will check? Else if what?
Else mid does not equal to element,
Mhm.
low equals mid, and then
A of
mid equals, yeah.
if uh, if element is lesser than A of mid, right? Then what happens?
Is less than A of mid.
Your element is less
Then
than A of mid. This
you make your mid your high, so
right.
mid equals to high.
No, what is the new high? You are saying
It's
that
mid.
if we have to change the value of high.
It's A mid is your new high.
You know,
Mid.
what is the value of low? 0. What is the value
Yeah.
of high? 4. Right? What is the value?
Mm-hmm.
0 plus 4 div 2 means 2. This is your mid, right?
Mm-hmm.
Now,
Yeah.
is this element is lesser than A of mid? Means you are checking, is this element is lesser than 90? If the element is lesser than 90 and array is already in ascending order, this means you will discard right half, right?
Yeah.
If you are
Mm-hmm.
discarding right half, this means this part is your new array, this part.
Yeah.
Yes, not this part. In fact, you will not consider mid part because this is your mid part. Only this part is your new array, right? If this is your new array, you are moving to the left side. What you will change? This is your new high, right?
Mm.
Low remains 0. but the new high is mid minus 1, right?
Yeah.
So new high is mid minus 1. Are you understanding why it is mid minus 1?
Yeah, because it's one below the mid because we already checked the mid.
Let's say all of these criteria are wrong. Then what will happen? If A equal to mid is equal to element, no. Is this element is lesser than A of mid? No. Then else what happened?
Else, element not found.
No, no,
No,
no.
sorry, else if it's then you have higher than.
Right.
If your element is higher than mid, then you would do mid low equals to
Mhm.
mid plus 1.
Right. So because you are moving low equal to mid plus 1. Why mid plus 1? Because you are moving to the right side. Here you are discarding right half array, and here you are discarding left half array. Discarding left half of the
All
array,
right.
right? So, and this process continue. That's it. This is the body of while loop. That's it. Okay.
Mhm.
Outside the loop, you will write if your found is still false. So if not found, then you will just output element not found. Okay. Now I'm going to comment this, and we are calling binary search method. We are passing the real array ARR, and we are passing, let's say, 67. Okay. So if
Okay.
I'm calling this method like this way and I'm running this, 67 found at position 0. Okay. You can see 67 it is at 0 position. And if you are writing 100, then, let me see. Something is wrong. I have to check. So we have to rectify this error. We have to keep this low plus high in a bracket, because if we are not putting bracket here, high will be divided by 2 first, then we will add low because of BODMAS rule. But if you are writing low plus high in a bracket, we are first adding them, then dividing by 2. Now, if we are running this code, 100 found at position 3. So if you are calling this binary search for 100, so you can see it is at position 3. And we can trace. I hope you are getting this code, right?
Yeah, I understand.
Okay. Now again, I'm shuffling these numbers. Let's say 56, let's say 80 is here, 67 is here, 9 is here, 10 is here, and 300 is here, and 200 is here. So in a jumbled way. Now we are writing code for bubble sort. Okay.
Okay.
You just quickly check your pseudocode part, and we are about to convert it into Java. So we
Okay.
are okay. This time, Doa, I'm teaching you how method can return entire array. Okay, so you can see this time, because we need this sorted array for binary search operation. So let's allow this method to return entire array. Okay, so if
Mhm.
your method is returning entire array, what you will do, you will write public. The return type is data type, then square bracket, then method name, then if this method is accepting as an any array, then again data type, square bracket, and then array name. And you will do something with the array. For example, let's say you are creating another array A here inside the method, and you are doing something with this. You want to return this entire array to the calling point. What you will write? You will just write return statement and just A without any square bracket. This is the syntax. Okay. Now, let's do it. I need sorted array for binary search. So we will call binary search later. But before this, ARR will be updated, and we will call bubble sort method, and in bubble sort method we are passing ARR. So you can see what kind of code we are about to construct. We are calling one method. This is our original array. We are passing this original array in the method. This method will do some kind of computation, some kind of sorting. And once sorting will done, we will return this sorted array here. And this entire method call will replace by the sorted array, and the copy will go to the ARR. So this means ARR will be sorted, and we can use this sorted array to the next operation. Okay.
Okay.
Now let's start. Okay. So this is the A array, and we will return this array A once we will finish the code. We are returning this A array. Okay.
Mm-hmm.
The return type int square brackets, method name, then int square bracket A. Now let's start bubble sort thing. So in bubble sort, we are creating one boolean variable swap, and the initial value of this is not false, it is true. Then we are running while loop, while swap. You can write while swap, or you can write while swap equal to both are same thing. Okay. Because in the while loop, what they are expecting, that something must be either true or false. If in a while loop you have something true, this means you will take entry into the loop. If in the while loop criteria something is false, you will come out from the loop. Okay. So while swap. In the while loop, we are updating the status of swap. Then we are running one for loop. For integer I equal to 0, I is lesser than a dot length minus 1 and I plus plus.
Mm-hmm.
Now I'm explaining this, why we are doing this. Let's say this is your jumbled array. 50 is here, 10 is here, 60 is here, 30 is here, and 40 is here. This is the array, let's say. Okay, this is initially this was ARR array, and once you are providing this copy to this A, then A will be created with the same value. Okay, the another copy. But the copy of this A is local to this method. It will release the method. It will release the memory once we will come back to the calling point. So now on local level, the name of this array is A. You are setting one variable swap, which is true initially. True is indicating that sorting and comparisons are needed. Comparisons are needed to arrange this array. True is just an indicator that maybe you need more comparisons to arrange this array in any order, either ascending or descending, basically. Fine. If you are setting swap false will indicate that array is sorted, you should come out. Array is sorted and you should come out from the loop. Come out from the loop. And come out from the loop means stop the process because array is already sorted. Okay. Now, I'm running this loop till length lesser than length minus 1. So if you are writing a dot length, so what is the length of this array? 5. You have 1, 2, 3, 4, 5 elements. What dot length minus 1? 4. And how many times you are running this loop? I is lesser than 4. So basically I is 0, 1, 2, and 3. So till 3 you are running this loop. Basically you are stopping this loop at the second last position. And why you are doing this? Why you are stopping this loop at the second last position? Because you will compare zeroth element. When your I is 0, you will compare it with the next element. And if they are in wrong order, you will swap them. When I is 1, you will compare your first element with next element. And if they are in wrong order, you will adjust them. When your I is 2, you will compare second element with the third element. If wrong order, swap them. When your I is 3, you will compare it with fourth element and you will swap them. That's why I will never go till 4, because you don't have any other element after this 4 to compare. Okay, that's why you are stopping this loop at the second last position. So if A of I is greater than A of I plus 1. I was talking about this. If A of I is greater than I plus 1, you will create one temporary variable and you are putting this ith element in the temporary. Then you are updating the value of ith element with, you are replacing it with I plus 1, and then you are replacing I plus 1 element with temp. Okay, and once this swapping is happening, you will change the state of swap. Swap is true again because it is indicating that maybe if you are arranging them, if you are swapping them right now, maybe you need it for the next iteration also. This is the code of bubble sort. This is the code of bubble sort. That's it. This is the ending of if. This is the end for loop. You will write this logic as it is. Maybe you will change names and all. This while loops end, and after finishing this, return A. Now let's see what is the value of ARR after this sorting. So we are just printing for integer I equal to 0, I is lesser than ARR dot length I plus plus, and you are printing. You can see after sorting what data we are getting. After sorting, we are getting 9, then 10, then 67, 80, 200, and 300. So you can see it sorts in ascending order, right?
Yeah.
But if you want to sort the elements in descending order, you will just change this sign, lesser than. This is lesser than. If ith element is lesser than I plus 1 element, this means it should go to the right side so that the bigger element should come before the smaller ones. Now, if you are running this loop, you can see now array is sorted in descending order. Is this clear?
Yeah, I understand. You can change the descending ascending according to your loop.
Right.
I mean, your criteria.
This thing is not important for tomorrow's exam. For tomorrow's exam, what main thing you have to keep in your mind, how method is returning any array, how method is accepting any array as a parameter, and how method, what is the syntax of returning any array from the method. This thing is important because they will not ask direct questions. They will ask indirect questions, like where you are arranging some array where it already holding objects, and on the basis of certain data you are arranging them. Okay, so just keep the simple logic in your mind, but syntax, you have to be very clear about the Java syntax. Okay,
Okay. Okay.
let's quickly write code of selection sort. Okay,
Okay.
again, this time I'm keeping it void only. Public void, or let's return the entire array after sorting. Static int bracket start. This is selection sort. We are taking this entire array here with name A, let's say. So selection sort technique, let's say this is your jumbled array. 60 is here, 30 is here, 50 is here, 40 is here, 10 is here. What is the rule behind selection sort? You are maintaining two loops. I is 0 and it will stop at second last index. Okay?
Okay.
Maintain another loop J. J will start always from I plus 1 because logic is that you are comparing 0th element with all other remaining elements. And you are considering that the very first element is your smallest element. Okay, so we are maintaining one in variable and which is indicating that this element is smallest. Now what you are doing, from the remaining part you will write some logic to find any element which is smallest. So in this remaining part, which one is smallest? 10 is smallest at
Yeah.
location 4. So what we will do, initially your min index was 0. Initially your min index was 0. But after doing some iteration on remaining elements, you come to the conclusion that actually min index is 4. Okay. So once you will find the smallest element at the fourth location and these two values are not same, then swapping will happen. 10 should come here and 60 should go to this place. Okay. So when your I is 0, J loop will start from 1 and 2, 3, 4. So for I 0, J loops 1, 2, 3, 4. When I is 1, J loop will start from 2, 3, 4. Okay. Because after
Okay.
first iteration, 10 is here, 60 is here, other elements are as it is. Other elements are as it is. So in for next iteration, you don't need to, for the next part, you don't need to consider this element in your iteration because it is already at appropriate place. So you don't need to check this. In the next iteration, when I is 1, means this location 1, you are finding smallest element from 2, 3, second, third, and fourth position. Once you will find out that there is no element which is smaller than 30, then swapping will not happen. Then in next iteration, I become 2, then you are comparing it with other element 3 and 4. Once you will find out, okay, 40, which is at location 3, is actually smaller than the element which is at 2, then swapping will happen. So this is the logic behind selection sort, where every time you are finding the smallest element and you are putting that smallest element at the appropriate place. So we are running for loop for the for I. So I is 0. This loop will stop at the second last position. So A dot length minus 1. Then I plus plus.
Mm-hmm.
Inside this loop, every time we are updating our min index. Min index is equal to I basically. We are considering ki, okay, if your I is 0, let's say this is the index of smallest value. Then we are running loop J so that we can find the smallest element from the remaining elements. So J is 0, J is not 0. J will start from I plus 1. And J is lesser than A dot length and then J plus plus. You notice I'm running this loop till last index because once your I is 3, then J will go till 4 so that you can compare third element with fourth element. Means you can compare last second element with the last element. Here, you are just writing one thing. If your A of J is lesser than A of min index, then you are just updating min index, which is J. Only this thing. That's it. And this
Okay.
is finished. This loop is finished. And after finishing this loop, basically what this loop is doing, this J loop, this loop is actually finding index of smallest element from remaining elements of an array. Okay. So outside this loop, what you will do, you will just write that if min index is not equal to, this is the not equal to sign. If min index is not equal to I, then only swapping will happen. So we are creating temporary variable temp equal to a of I is equal to a of min index, and a of min index is equal to temp. That's it. And program is done. This is closing of for loop, and we are just returning this array A. Okay, now let's see. First, let's see the impact. If something is wrong, I will correct it. I am just commenting this part. Let's not do bubble sort. This time we are calling selection sort. ARR. I'm calling this method, so I'm just writing the name of the method and I'm just passing this array. Okay. Now let's see. 9, 10, 67, 80, 200, 300. It is things are in sorted manner, right? Let me explain this. This is your array. Or you tell me, are you understanding this?
Yeah, well, the array and selection sort, if it's already sorted, there's no need to not sorted.
You don't need to trace, right?
Yeah.
We already covered this topic in paper 1, how this algorithm works, right?
Yeah, that's fine.
Very particular about the like the synthesis of this Java language, and tomorrow you will be like very careful what will be the name of the array. If it is object, if it is array of object, let's say this array is actually array of object, then you will write a of I dot some accessor method, let's say get title. Okay, so let's say you are arranging all the books in order of their title, so AI is the, let's say, object of book class. Okay, it is object of book class, and you want to arrange this array in dictionary order. So if a of dot get title dot compare to, so compare to is a method which will compare two strings. If ai dot get title dot compare to ai plus 1, I'm talking about in context of verbal sort, ai dot get title lesser than 0, then you will do some kind of swapping. Okay,
Okay. Yeah.
this type of code you will do. Okay.
Okay.